In this class, we will solve the problem 6.1 of Griffith 4th edition, Introduction to Electrodynamics. The problem 6.1 is calculate the torque exerted on the square loop shown in figure 6.6. This is the figure 6.6 due to the circular loop. This circular loop, assume R is much greater than A or B. The square loop is free to rotate. What will its equilibrium orientation to be? So there are two parts in it. Uh, we have to find the torque exerted on the square loop due to this circular loop. So we will see that. Now we will solve this problem. Here you can take that at this point, circular loop, the magnetic moment is M1 and magnetic field is P1. Here the magnetic moment is M2 and magnetic field is P2. Now we have to find the torque on the square loop due to this circular loop. So by definition, the torque is M2 cross P1. So we will see what is that M2 cross P1. Conventionally, we will take this as z-axis. This is z-axis, and this one is y-axis. Sorry, y-axis, and the other one is x-axis. So x, y, z. So now here the r cat is we are considering along the y direction is equal to y cat. R is a generalized coordinate system. Then M1, what is M1? M1 is along this z direction. So M1 is equal to M1 z cat. And M2 you can see here. M2 is along this direction. That is M2 y cat. And by definition, the magnetic moment is area multiplied by the current. These are the things we have to remember. Now you apply this here. That is the magnetic field for a dipole. This is circular loop is nothing but a small magnet. We can take it as a magnet. It will create a magnetic field, tiny magnet, or it is called magnetic dipole. So which is equal to mu naught over 4 pi 1 over r cube 3 multiplied by m1 dot r cat multiplied by this r cat minus this m1 is along z direction, so m1z. So this will be equal to this m1 is equal to m1z cat, and here this is along the y direction, r cat is y direction. So z dot y, it is perpendicular, so this will be equal to 0. Only the second term retained, that is minus m1z. So this minus I am taking out. This will be equal to mu naught over 4 pi 1 over r cube this m1z cat. Now, what is the torque? By definition, torque we have shown, that is M2 cross product P1. M2 we know M2 is equal to here. M2 is along y direction. M2 mu naught P1 is equal to mu naught. Of course, one minus negative sign will come. Minus M2 mu naught over 4 pi 1 over r cube M1. The M1 is equal to M1 along z direction. M2 is along y direction. So M2 is along y direction. So y cat, this P1 is along z direction. Y cat cross z cat. So this is equal to this x cat. This is equal to x cat. So This can be, now we have to multiply this M2 into M1, M1, M2. So M1 is this side by definition A into I, area into current. That is pi A squared I. M2 is, this is the square loop. So which is equal to P squared I. If you multiply M1, M2, you will get pi A squared P squared I squared. So I am simply writing that as a ABI power whole square. So I am replacing M1, M2 as uh, ABI whole square. This pi and this pi will get cancelled. This pi will get cancelled. So this will become mu naught over 4 and M1, M2, AB I power whole square. This is R cube. This Y cross Z is Y cat cross Z cat is X cat. At equilibrium, the torque is equal to 0. That means this M2 and P1 are parallel to each other. Here you can see P1 is along Z direction, so M2 must be equal to Z direction, but negative Z direction. This is negative Z direction because both must be parallel. This is at the equilibrium condition. So thank you very much for watching my video and supporting me continuously. Thank you very much.